Okay, listen up. If you are sitting for the Cambridge Computer Science exams, whether we're talking about syllabus 0417, 0478, 0983, 0984, 2210, or especially the grueling 9618, there is one module that is absolutely unavoidable. I'm talking about the need for security of data and systems. And yet, year after year, thousands of students step into the exam hall and literally bleed marks right here. Today, in this explainer, we are slicing through the confusion. We're going to look at two classic student approaches that fail completely. We've got Alex, who just overloads the page with raw facts, and we've got Sam, who panics, rushes, and completely misses the point. We're going to tear down their flawed methods, show you exactly how to avoid their fate, and teach you how to master the paper with absolute precision. Let's dive in.
Here's our exact roadmap for today. 1. The examiner's playbook. 2. Core security principles. 3. The execution framework. 4. Critical analysis strategies. And finally, number 5, the top 3 fatal mistakes.
All right, Section 1, the examiner's playbook. It's time to pull back the curtain and look at the secret language examiners use to actually assess your understanding.
So here is a question I get all the time. Why do students find interpreting complex binary representations so incredibly hard? When we look at data security and system security, binary interpretation is the absolute foundation. You literally have to extract data from binary representations, perform your calculations, and then draw evidence-based conclusions from that data. It shows up in every single exam series, every single one. Yet candidates constantly drop easy marks here. Why? Well, it's because under the pressure of a ticking timer, they treat binary as just a simple math problem instead of the logical foundation of data security. You have to realize that when an encryption key or an access right is represented in binary, you are just translating numbers into a different base. You are determining the actual security posture of an entire computer system. If you get the binary wrong, your whole security analysis falls apart.
Now I want you to burn this quote into your memory, straight from the source. The assessment framework prioritizes analytical depth over superficial breadth. What does that actually mean for you when you're sitting at that desk? It means raw facts are simply not enough. Listing 10 different types of malware or reciting the exact textbook definition of a firewall will absolutely not get you top marks if you can't explain how and why they function within the specific context of the question. Think about it from the examiner's perspective. They are looking for connected, conceptual understanding. They want to see that you can take your core knowledge of data security and transfer it to a completely unfamiliar scenario. A superficial, weak answer just says something like, encryption scrambles data. But an analytical, top-tier answer, that explains exactly how asymmetric key pairs secure data in transit against interception within a specified network architecture. That depth is what unlocks the highest grade boundaries.
Moving on to Section 2, Core Security Principles. Let's break down the distinct cognitive domains that the assessment objectives are actually targeting.
Okay, I want you to picture two types of students. First, we have Alex. Alex sees a question about securing a computer system, panics, and just word vomits every single security protocol they've ever memorized onto the page. It's a complete overload of raw facts. There's no structure, there's no application to the scenario, it's just a data dump. Then, on the other side, we have Sam. Sam reads the question, gets terrified by the clock counting down, rushes the answer, and completely ignores the command word. The prompt specifically said evaluate, but Sam just wrote describe. Both of these approaches are fatal. They just bleed marks. We absolutely need a systematic approach to break this cycle. And before we continue and show you that exact system, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Welcome to Section 3, the execution framework, and the all-important method mark strategy. This is where we turn knowledge into actual points.
What you're looking at right now is a specific, razor-sharp 5-step procedural framework for tackling literally any complex data security question they throw at you. Step 1, deconstruct. You need to tear the question apart. What is the command word? What is the exact context? Step 2, extract. Pull out the relevant data. Find those binary representations or the specific system constraints hidden in the prompt. Step 3, select. Choose your analytical framework. Are we evaluating an encryption method, or are we looking at physical system security? Step 4, execute. This is where you put pen to paper with clear notation. You must show you're working. And finally, step 5, present. Deliver your final answer using the correct, precise terminology. If you follow this exact sequence, I guarantee you will never miss a hidden requirement again.
Let's look at how this framework translates into an algorithmic problem-solving sequence, which is absolutely essential for these exams. You must show step-by-step decomposition. Step 1. Identify the given information. Step 2. Break it down into logical, bite-sized steps. Step 3. Solve it systematically, line by line. Step 4. Check for reasonableness. Honestly ask yourself, does the security solution actually make sense for a tiny local business, or are you recommending enterprise-level overkill that doesn't fit the context? And Step 5. Make justified recommendations. This algorithmic sequence is exactly how you prove to the examiner that you possess that higher-order analytical depth they are desperately looking for.
And all of this brings us to the holy grail, the method marks strategy. I need you to keep this in your head at all times. In Cambridge computer science exams, the process, meaning extracting from binary, performing your calculations step by step, and systematically drawing conclusions, is literally just as critical as the final answer itself. You get marks for showing your clear working. You get marks for your logical structure. You get marks for your evidence-based reasoning. Even if your final recommendation is slightly off because of a tiny calculation error, a flawless, logical process will still capture the vast majority of the points available. You are farming for method marks.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's get back into it. Section 4, Critical Analysis Strategies. Consider this an interactive workshop.
Let's look at a side-by-side comparison of 2 real-world styles of answering. I want you to see if you can spot the flaw. Look at the weak answer first. It just lists raw facts about 2 different security systems. It says, System A uses passwords. System B uses biometrics. That is a classic Alex answer, right? It's just a disconnected list. Now look at the strong answer. It identifies similarities and differences, but it uses comparative connectives. It says, while both System A and System B control access, System B's biometric approach mitigates the risk of credential sharing, whereas System A remains vulnerable to brute force attacks. Do you see the difference there? The strong answer doesn't just list facts, it uses connectives like whereas to actively connect the facts to the underlying security risk. That is how you analyze.
To make sure you consistently write like that strong example, you absolutely need this comparative analysis checklist. Seriously, take a mental screenshot of this right now. Whenever a question asks you to evaluate or compare data security methods, you must do 4 things. 1. Identify similarities and differences. Don't just do one or the other. 2. Use comparative connectives. Words like whereas, however, or in contrast are golden tickets for analysis marks. 3. Support every single comparison with hard evidence pulled directly from the prompt. And 4. Draw relative conclusions about which method is actually better for the specific context they gave you. This checklist is your ultimate shield against losing analysis marks.
We are entering the final stretch. Section 5, the top 3 fatal mistakes, pulled straight from the principal examination reports. Listen, you've done the hard work. You've memorized the theory, you understand the frameworks, but none of that matters if you fall into the same traps everyone else does. Let's look at the specific, entirely preventable errors that cost candidates easy marks every single year.
Here they are, straight from the examiner's red pen. Fatal mistake number 1. Students completely forget to check overflow and edge cases in their data security calculations. You do the math, but you forget the edge case, and boom, you lose easy process marks. Fatal mistake number 2, forgetting to check boundary conditions. When you are writing an algorithm or mentally testing a security protocol, if you don't test the absolute limits of the data input, your answer is considered incomplete. And fatal mistake number 3, and honestly, this is the biggest one of all, answers are not specific to the context given in the question. I can't stress this enough. If the question is specifically about a hospital's patient data and you just write a generic textbook answer about a school network, you get 0 application marks. Context is king. You have to tailor your knowledge to their scenario.
Which leads us directly to a massive examiner alert. The examiner reports consistently reveal that candidates confuse key terminology. You will literally see students swap the terms data privacy and data security throughout their essay, as if they are the exact same thing. They aren't. Data privacy is about authorized access and policies, while data security is the technical mechanism protecting it. Never, ever assume the examiner knows what you mean. Always define your terms clearly before you use them in your extended responses. Show clear working and use the correct terminology. That is how you win the paper.
So, with all this pressure, how do we actually lock this down when the exam timer is ticking? Here is a super quick study hack. Create your own mnemonic for the need for security of data and security of computer systems using the first letters of key terms. Whether you need to remember the steps of our procedural framework, deconstruct, extract, select, execute, present, or the core principles of confidentiality, integrity, and availability. Build a quirky, memorable device. That way, when the exam timer starts, you just scribble your mnemonic at the top of the blank page, and you instantly have your entire structural framework ready to go before you even read question 1.
Let's pull everything we've talked about together into your ultimate blueprint to success. These are the 3 rules that guarantee top marks. First, command word decoding. You have to speak their language. If it says evaluate, you must compare and conclude. If it says describe, you just detail the characteristics. Second, PEAL framework application. That's point, evidence, explanation, link. Every single analytical paragraph you write must follow this PEAL structure to ensure you hit that required analytical depth. Third, the time management matrix. Don't be like Sam. Do not rush the high-value analytical questions just because you spent way too long perfectly defining basic terms at the start of the paper. Stick strictly to your allocated minutes per mark.
Look, the data here speaks for itself. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
You now have the ultimate playbook. You know exactly what the examiners want, you know the fatal mistakes to avoid, and you know exactly how to structure your analysis to guarantee method marks. So, drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.